Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see what today's problem, longest subarray with sum divisible by k, right? So what they're saying is, like in the input, there'll be an array given, right? And a k will be given. Now we want to find the length of the longest subarray, right? Subarray with sum of the elements divisible by k. Okay. So for example, in this example, right? So the length of the longest subarray is 4. That is, this is a subarray 7614. Now if you do the addition of these elements, right? 7614, it is 18. And 18 is divisible by k, right? Divisible by k. Okay. So what we want to find? So length of the longest subarray whose sum of the elements are divisible by the given k. Okay. So this is the a problem asked. Okay. So now there are two approaches, right? Let's see first the naive approach. So naive approach would be like you traverse through all the subarrays, possible subarrays, right? I equal to 0 to n, right? And there'll be two loops, right? J equal to I to n. Okay. Now these two loops, right? In J equal to I, these two loops will traverse through all the subarrays, right? And then you can calculate the length of the longest subarray. You can calculate the sum, right? And whatever is the length of the longest subarray, you can have the answer, right? So this approach will take O of n square. Okay. So we want to find a better approach, right? Okay. So the better approach would be, let's say, for example, let's take two examples: 7, 6, 1, 4, 5. So what we are going to do is we are going to have prefix sum. We will calculate the prefix sum. Prefix sum is nothing but, for example, right, 7. So 7, for example, prefix sum, right? Okay. Okay, 7 plus 6, 13. So till the point, right, till this location, it will be the addition of all the elements from 0 to this I. Okay, 7 plus 6, right, 14. Then this one, for 4, right, it will be 18. For this, it will be 18 plus 5, the previous sum, 18 plus 5, 23. Okay. So now, so we will have this prefix sum. Okay. And what we'll do at each point, we'll have, once we have, for example, now we calculate this prefix sum, right? 7. And what is k? K given is, for example, 3, right? K is 3. Now we'll check this sum. We'll have a sum, prefix sum, right? We'll check whether prefix sum mod k equal to 0 or not, right? In this case, so 7 mod k, it's not equal to 0. So we'll go ahead. 7, so 13, directly 13 mod 3. It's not divisible by 14 is not divisible by 3. Then 18 is divisible by 3. Okay, 18 is divisible by 3, right? So till now, the length of the longest subarray is 4, right? 4. I plus 1. If I is this, I plus 1 will be the length, 4. Okay, and 5. 23 is not divisible by 3. Okay, so the length of the longest subarray is 4. So now consider this case. Okay, let's consider this one. This example, 2, 7, 6, 1, 4, 5. So what is the prefix sum? Let's calculate the prefix sum. So prefix sum would be 2, 9, 9 plus 6, 15, 16, 20, 25. What is k? K equal to 3. Now what we're going to do, this is prefix sum, right? And we'll have remainder as well. Remainder. Okay, remainder. So 2 mod 3. What will do? 2 mod 3. Right? 2 mod 3 will be 2 only. 9. This is what? 9. 9 mod 3 is 2, 7. Right. Yeah. So, yeah, 9 mod 3 is what? 0. Right? 0. Then 15 mod 3 is what? 15 is, yes, 5. 5. Right? 5. 16 mod 3 is 1. Right? Then 20 mod 3, it gives us 2. Right? 2. And 25 mod 3 gives us what? 24, 1 again, 1, right? So we have these remainders, right? We have these remainders. Now, if you observe some pattern, right? So there are, this 2 remainder has appeared twice, okay? 2 remainder has appeared twice. So when this is the case, right? When this is the case, that means we have found out that means, see, it will be like the length will be what? The length of the subarray will be this, the next location, from next location till this location, this subarray will be divisible by k. Okay, will be divisible by k. Okay, so if you see, right, if you have this, look, right, now this 7614, what is 7614? 7614 is 18. 18 mod 3 is 0. So this is a subarray whose sum of the elements are divisible by k. Okay, so this is a pattern we are going to follow, right? There are two one scenario we saw, right, wherein there was subarray starting from 0 to this element I, right? Where remainder was 0 directly. Remainder was 0, right? So 7 plus 6 plus 1 plus 4, right? We did 18. 18 remainder was 0. And here the case is what? The remainder here is 2. Okay. The remainder here is 2. So what we're going to do, we are going to store the remainders, right? We're going to store the remainders. And whenever we find the remainder, which has already occurred, right? So we have a subarray whose sum of the elements are divisible by k. Okay. So let's see. And like, yeah. Now see what we'll have. This is the code. Okay. So we'll have this map. We'll store the remainders in this map. Okay. Then we have sum, prefix sum, right? Remainder and max. Max is to store the maximum subarray length, right? So now we are going to iterate. We are going to have this prefix sum, right? Into the sum, and then we'll have remainder. Okay, we'll have remainder here. So if remainder is 0, so this is the case, right? When will the remainder 0? So 7 6 what 7 6 1 4, right? So we reached a stage, right? 7 plus 6 plus 1 plus 4, right? We reached a stage 18. 18 mod 3 is 0, right? So we reached a stage where remainder was 0, right? Remainder was 0. So what we'll store max as I plus 1. Okay, I plus 1, and we'll continue. Okay, then what we're doing here is, if remainder becomes negative, then what we're doing here is, I'll explain this case later on. Okay, so other cases, what other cases, see, now we are checking whether the remainder, what was the remainder, whether it is present in the map or not. If it is, then what we're doing is, see, if it is, then we are this I location, what we're going to store in the map, for example, right? For example, uh, this case, right? So first remainder, right? When you found this remainder, we are going to store 2 comma in the map, right? Key and value. Okay, 2 and the location. What is the location of this? 0. I is 0, right? 0. Then 0 1, right? 5. This is the map, right? This is the map we are storing. Okay, 5. What it would be? The key would be the remainder, and the value would be the ith location, the position. Okay, 5 is 2, 0 1 2. Then 1 is what? 3. And see what we are doing, we are just going to store the initial remainders. Okay, again, if 2 comes, we are not going to store 2 again. We are going to check whether 2 has appeared or not. So here we are going to check, right? Whether 2 has appeared or not. Okay, 2 has appeared. So what we are doing, yes, the map contains this key. Okay, the map contains this key. So I minus, what we're doing, map.get will give us the location of the previous remainder. Okay, so I minus what is I here? So I is what is it? Just 2 minutes. So I is 0 1 2 3 4, right? So 4 minus, what is the position of the first two? It's 0. So 4 minus 0 is 4. Okay, 4 minus 0 is 4. So here it is, right? So we'll store in the max. Okay, else if we don't find that remainder, we're going to put in the map and the ith location, and we're going to put the position of that element, of that remainder. Okay, it's simple. And then we are going to return max. Okay. Okay, now let's consider this case. I'll explain the C++ code as well. Okay, so let's explain this. Let's see this case. Okay, so remainder, for example, -1 9 0. The array can contain negative elements as well. Okay, so and let's say k equal to 9 is given. K equal to 9 is given. Okay, k equal to 9 is given. Now what we're going to do, -1 mod 9, what it is going to give us? -1 itself, right? But we are not going to store -1 in the map. We are not going to store -1 in the map. Instead, what we're going to do is, we'll do what the remainder, right? If the remainder is negative, in this case, right? Remainder is negative in this case, -1. So what we're going to do is -1 plus k, we are going to add k. Okay, and 8. Okay, -1 plus, if the remainder is negative, if the remainder is negative, we're going to add k with this, right? In order to make it positive. So adding k to the negative remainder will give us the value from 0 to k minus 1. Okay, 0 to k minus 1. Why we are doing this? To make it consistent. For example, right, in this case, -190. So let's say, what will be the remainder here? The remainder here, according to this, -1 is the remainder, and then we are going to add k to it. So it will give us 8. So remainder we are storing here, right? Then 9 mod 9 is what? No, sorry, 9 prefix sum, right? 9 minus 1 8, right? And 8, it will give us 8. Okay, it will give us 8. So if we calculate the prefix sum, right, for this array, right? So it will be what? -1. Then we'll have 8 over here, 9 minus 1, 8, right? And 8 plus 0, it will be 8. Okay. Now, if we calculate the sum, right? If we calculate the sum, sorry, the remainder, this is prefix sum we have calculated, right? And the remainder, what would it would be? -1 mod 9, right? It will give us -1 itself, right? So what we are doing according to our formula, -1 plus 9, we are going to store 8 here, remainder, right? And then 8 mod 8, 8 mod 9, right? 8 mod 9, right? It will give us 8 only. So we are, so in the map, right? In the map, how it will be? So in the map, we are going to store 8, this 8, right? And the ith location, right? It will be 0. Now what we are going to do is, we are going to do what? This 8, right? We are going to check 8 mod 9, it will give 8, and we're going to check whether it is there or not. So yes, it is there. So what we'll do, this I, what is 0 1 2, right? The indexes are, right? So this I 1 minus 0, right? This 0, right? It will give us 1. Okay, it will give us 1. Now we'll again come to this, right? Again 8. We'll check whether it is there in the map or not. Yes, it is there. So what we'll do, 2 minus 0, which will give us 2, right? Which is the right answer, 2. Now how 2? 2, because here, this is a subarray, 9 plus 0. 9 plus 0 equal to 9, which is divisible by 9, right? This is the maximum length of the subarray. So if we had not stored, right, this 8, it wouldn't have been consistent. If we would have stored -1, for example, right? If we would have stored, just give it to this, okay? Yeah, if you were to store directly, right, -1 mod 9, what it will give? -1 itself, right? -1. So if let's say if we store remainder -1, right, and 0, the location, and then 8 would have come, right? 8 mod 9 would give us 8. We'll check in the map. No, it is not. Then we'll store 8 and 1, right? And again, when we encounter 8, we'll check in the map. Yes, it is there. So what we'll do? The index of this is 2, 2 and 1, right? 2 and this one. 2 minus 1 equal to 1 we would have got, right? Which would have been the wrong answer. We would have got this subarray, which would have been the wrong answer, right? So the right answer is 9 plus 0. This is a maximum. So that is why, in order to make this consistent for the negative elements, we'll simply add -1 plus k, right, which will give us 8, and which will give us the right answer according to our approach, solution approach. Okay, so that is why what we're doing here is remainder. If it is negative, we'll add remainder with k. Okay, so this is the solution. This works. I've checked it. Similarly, yes, it is accepted. Similarly, we have same C++ code, right, with minimum differences. Here we have used unordered map, right, and we are doing exactly the same thing here. And for to finding the element in the map, we have to use this, right, and then max we are calculating here. Okay, max. Otherwise, we are putting in the map, right? If I not found, okay, if the remainder not found, if remainder not found, sorry, yeah. So this is it. This is solution. I hope you have understood the solution. Please subscribe to my channel. It will motivate me. Okay, thank you very much. Have a happy, healthy, and a great day. Thank you.